Okay, Algebra 3 Trig, welcome back to section 1.2. This is part 3 of this section. So in this section, I'm going to give you functions, and our goal is going to be finding the domains of functions algebraically. So when an input, also known as x values, results in an expression that is not defined as a real number, for example, like a square root of a negative or a 0 in a denominator, then it is not in the domain of a function. For example, I'll show you a simple example right here on the side real quick. So say if I got f of x equals 3 divided by x. If we look here, we would say x cannot be 0. So it could be any number in the world except not 0. Because if it was 0, 3 over 0 is not okay, and that would be undefined. So that's the real basic gist of what we're doing here. So for example, let me show you another example. So say if we have a square root. So say if we have the square root of x, here's a really basic one. X can be 0 because, x can be 0 because the square root of 0 is 0. X can be a positive number because you can take the square root of any positive number. But x cannot be the negative numbers, because you can't take the square roots of negative numbers and get a real number answer. You get an imaginary number, but not a real number. Okay, so what you would say for there is you would say x has got to be all the numbers greater than or equal to 0. Or, another way of putting it, you can say x cannot be less than 0. Probably a little more confusing, so that's why we tend to go with this one, of what it can be when it's in inequality. Okay, so again, inputs that make the denominator 0, if you have an x in the denominator, or that yield a negative radicand in an even root, such as square root and fourth root and sixth root, etc. They're considered not in the domain of the function, like I showed you with the basic examples. Now let me show you some more examples. So in A, to find the domain of the function, I notice I have a fraction. So I look in the denominator of the fraction, and I know that the denominator is not allowed to be 0. So we set it up as not equal to 0. By the way, I do want to iterate that it's only when a variable is in the denominator. Like if you had, say, a function of x over 5, this is just a side problem here. That's okay. X can be in any number in the world because there's no x in the bottom. So there's only a restriction when it's a fraction where a variable is in the denominator. Okay, and then you have your equation set up, so you would just solve it. So you would add 3 to both sides. So you would say x is not equal to 3. Now, I'm okay if you leave that as your answer. Perfectly okay with that. I'm not too technical, as you guys know. But a technical way of putting it is in curly brackets, and we would say x can be any number in the world, except x cannot be 3. So that's just a fancier way of writing it, which I'm not concerned about. Okay, let's try another one. Letter B. We have another fraction, and we have variables in the denominator. So let's figure out what the domain is. So we set it not equal to 0. And how would we solve this? Well, this guy's a quadratic. You can either use the quadratic formula, or you can try to factor, which I'm going to try to do here. Remember your signs. C is a negative, so that's plus minus. And two numbers that multiply to get 3 are 1 and 3. And we want them to subtract to get 2. So that would be positive 3 and 1. 3 and the double check. Remember, the rule is multiply to get C, add or subtract to get B. So the check, mental check, is 3 times negative 1 is negative 3. And 3 minus 1 is 2. So that's good. So that's factored. It's not solved yet, though. So you would say, remember, when it's a binomial, what you want to say is x cannot be equal to negative 3, and it also cannot be equal to 1. So x can be any number in the world, except it cannot be equal to negative 3 nor 1. Because if it was negative 3 or 1, it would make that denominator 0. Okay, letter C is actually, we don't have a fraction here, and we don't have a square root. So there's actually no restrictions here. The domain is literally all real numbers. All real numbers. Every number in the world, if we plugged it in for x, would turn out to be a real number output. And letter D, the one with the square roots. So this one, here's the setup. We take the radicand, that's whatever is inside the radical, and we would say whatever's inside a radical can be positive or 0, so greater than or equal to 0. Okay, because remember, we can't square root negatives. So we're going to solve this. So add 4. Then, of course, divide by 2. And there's your domain. It's telling you, this guy is telling you what the x's can be. It can be any number two or higher. 2 or higher. Any number greater than or equal to 2. So that's how you find domains. It really comes down to fractions with a variable in the denominator, or a square root, which you would set up greater than or equal to 0. And if it's not any of those two things like A, B, D, if it's like C, where it doesn't have any of those two things I mentioned, then it's all real numbers. Okay, next part is finding the domain and range by looking at a graph. Now, this is actually very easy. It's people seem to be intimidated by this, but I'll break it down nicely for you. Just be patient. So remember, the domain is the set of inputs. Really, it has to do with the x coordinates. So found horizontally on the x-axis. And then the range has to do with the y coordinates. It's the set of outputs found on the vertical y-axis. So here, I know there's 3 graphs, but focus right here on this graph. This is the actual problem that it will be presented to you as. And then the second and third graph are just breaking it down of how you want to look at the domain and look at the range. So for the domain, it's really, if I trace it, here's the leftmost part, and that goes to the left negative 4, and it goes to the right. It's continuously going and then stops at 4 all the way to the right. So as you can see here, we would say the domain is negative 4 to 4. By the way, this is what we refer to as interval notation. It's the way of writing it where it's not so fancy. It's just showing the intervals, the two numbers that the graph is drawn in between continuously, like it's flowing between these numbers. I hope that makes sense to you guys. So then the domain, the third graph, is just breaking it down of how the range would look. The range has to do with how low it goes to how high it goes. So it goes down to -3 on the y-axis, and it goes up to 6 on the y-axis. So we would say the range is -3 to 6. By the way, you might be notice on these for domain and range, I'm using squared brackets. That is because when we're listing domain and range, squared brackets with a number means it includes that number. So I'll show you the instance shortly of when we would use parentheses. So example 6, I'm going to determine the domain and range of the functions. So let's just put D for domain and R for range. So the domain is from -4 to the left. How far left does it go? -4. And how far right does it go? It's going to the right forever. So that means to infinity. And infinity is when you use parentheses. Actually, there's another scenario when you use parentheses. It would be if you had like an open circle at a number that's bordering. But unfortunately, I don't think that comes up on this page. All right, and then the range has to do with how low to how high. So it goes as low as 0 on the y-axis, and it is technically going up forever gradually as well. A lot of people put 3 there, but it is an arrow that's going up forever. So that's up to the positive infinity. So that's how we do domain and range. Let's just show more examples now. By the way, don't worry about the function that's given. We're just doing it by graphing, okay? So if we were to take a look at B, actually, if we look up here, side note, if we were to look at the function, we would go, hey, what's the domain there? It's all real numbers. There's no fractions with an x in the bottom, and there's no square root. So that actually is going to be all real numbers. So let's see what it's going to look like in interval notation. So the domain, a lot of people want to put down this. I'll put a wrong answer on the side. They want to go, oh, it's going from -2 to 2. So they're going to put that there. No, we're not going to do that. No. It is, again, the big rule of thumb is you're dealing with arrows here. And those arrows are technically going left forever and to the right forever. -infinity to infinity. Even though it doesn't look like it's going left forever, it might have to go, like, if it's going right forever, it might have to go a mile into the atmosphere to go another inch, but it is still technically gradually going right forever, even if it's microscopically. And then the range is all the way down to all the way up forever. So that's also -infinity to infinity. Just as I said, when you have infinities here, that actually means all real numbers. Just like we said when we were looking back here at the function. Okay, let's take a look here at domain and range. Oh, I should clarify here when I was talking about the -infinity to infinity by looking here at the equation, that actually just had to do with the domain, not the range. All right, letter C. So letter C, actually, if you take a look at the function, there's no fraction or square root, so the domain's definitely going to be all real numbers. I'm just tying in from 5 minutes ago to now. But left, it is going left forever towards the negative numbers, and it is going right forever. I made a little mistake. I should not put a square bracket with infinity. I need to put parentheses. So it's very similar to to letter B, same domain there, going left forever and right forever. Now the range, again, look at the y coordinates. It's down here at -4, and it is going up forever to infinity. And then letter D. So the domain is in between two numbers, so it's in between 1 and 5. All right, right here, 1 and 5, left to right. And then the range is the y, we're looking at the y-axis, so low to high. That's 0 to 2. Okay, guys, so we discussed a few things here, finding the domain and range, and the domain of functions. So that was the end of section 1-2, part 3. So what did that prepare you with? If we scroll down, my lesson today prepared you with getting right here, numbers 16 to 24 and 25 to 30. So you guys should be good to go now on your assignment. Have a good day.